Hello dear students, my name is Ujjal Shrestha, and in this video we're gonna learn about exponents and radicals. And this topic usually comes in a lot of tests, exams, especially SAT exam. So in this video we're gonna dive deeper into this topic and learn as much as possible. And what is exponents? Exponents is nothing but just a repetition of itself. For example, let's say we have 2 raised to 3. It means that 2 is being multiplied by itself 3 times. 2, which is 8. And another fact about exponents is if the bases are the same, then the exponents must therefore be equal. What does this mean? It means that, for example, if we are given 2 raised to 2 and 2 raised to a, and for these two expressions to be equaled, a must equal to 2. So, and 2 and a are the exponents with the same base 2. So that means that a must be equal to 2. And another fact is square roots are just fractional exponents. And what does this mean? It means that, for example, if we are given a and this is nothing but 2 raised to 1 over a, and square roots right here is nothing but a fractional exponents. That means a over 1 over a is the fractional exponents. Number 3, the order in which we do the squaring and the cube rooting does not matter. For example, if we are given 2 raised to 2 bracket 3, so it means that it is equal to 2 cube and square. So these two terms are the same thing. And one more thing that we need to be very careful. And in tests like SAT, it tests on simplifying square roots, also called surds. For example, if we are given to solve this square root of 49, it's nothing but a 7. And how do we get this? Square root of 49 is equal to 7 square, and we know that the square root is a fractional exponent. So we can write it down like this, and finally we end up with 7. And I want to first tell you that I'm using College Panda book, so you can also look up into College Panda book and you can practice with me. And just right here, it's exponents and radicals, and you can see the law and examples. So law number 1 says that anything raised to 1 is itself. For example, I have 2 raised to 1 is itself, which means it's a 2, and x raised to 1 is nothing but x. And anything raised to 0 is always equal to 1. For example, 1000 raised to 0 is always 1. Any number a raised to 0 is always 1. And number 3, if we have the same base, then we can add their exponents. As you can see, we can add m plus n. And right here, if we divide with the same base, then we can subtract their exponents. For example, we can write it down like this: xm multiply x negative n. And as we know already from the law number 3, that we can add the exponents if their bases are the same. So x m minus n. And now let's get into the question and solve as many questions as you want, because in math, the fact or theories is only 30%. And to be really proficient in math, the 70% of the time, you have to do a lot of practice, solving a lot of problems. And let's get into question number 1. In question number 1, what is the value of a? All right, what is the value of a? All right, we can do this. So here, a raised to negative 1 over 2. And we can flip that term upside down. We can write it down like this. Right? Equal to 3. And we can take a square in the both side. 1 over a and as we know, a raised to 1 over 2 multiplied by 2 cancel out, and we're just left with a. So in this case, it's a 1 over a. 3 squared is 9, so we get a equal to 1 over 9. So answer B is our right answer. Question number 2. Let n equal to 1 squared plus 1 raised to 4 plus 1 raised to 6 plus 1 raised to 8. What is the value of n? And we already know that 1 raised to anything is always equal to 1. All right? So here, our last term is 50. And we can see that it's even 2, 4, 6, 8. Right? And our last term is 50. We can find that we have 25 terms, right? So n equal to 1 plus 1 plus 1 plus, it's going to be 25 ones, all right? So n is 25. And question number 3, if 4 raised to 2n plus 3 and 8 raised to n plus 5, what is the value of n? So this is the question where we have to make our bases equal. And the common factor here between 4 and 8 is 2. So let's make our bases 2. As you already know that 4 equal to 2 raised to 2 and 8 equal to 2 raised to cube. And we can write it down like this, 2n plus 3, 2 cube n plus 5. So if we have the same base, then exponents are equal. So 2n plus 3, 3n plus 5, and 4n plus 6, 3n plus 15. So 4 minus 3, n, 15 minus 6, 9. So our final answer is 9. And let's go to the question number 4. If 2 raised to x over 2 raised to y is equal to 2 raised to cube, then x must equal. All right. So we need to find the equation, guys, here. And we can write it down, this term, like this. X minus y, all right? And 2x minus y equal to 2 cube. And if their bases are same, their exponents are equal. So x minus y equal to 3, and x equal to 3 plus y. So our final answer is A. Now let's go to question number 5. If 3 raised to x equal to 10, what is the value of 3 raised to x negative 3? All right. So 3 raised to x negative 3 can be written as 3x over 3 cubed. And we already know that 3x equal to 10. So we can substitute that value. 10 raised to 10 over 3 cubed, and we know that 3 cubed is 27. 3 into 3 into 3, is 9, 93, 27. So our final answer is 10 over 27. Number C. Now let's go to the question number 6. If x raised to 2 multiplied by y raised to 3 equal to 10, and x raised to 3 and y raised to 2 is 8, what is the value of x raised to 5 and y raised to 5? So we already know that if we multiply this term, then we can add their exponents like ax, a plus b. So as we can see here, we can see the pattern right here. That's a 3 plus 2, 5, 3 plus 2, 5. So we can use this formula, this concept, to solve this problem. All right, and we just need to multiply these two equations. X cubed y squared 10 multiply 8. So it's x5 y raised to 5 and 80. So our final answer is D. Question number 7. If a and b are positive, even integers, which of the following is greatest? In the number line, positive integers are 2, 4, 6, and should be positive. All right. Which of the following is greatest? And a and b are positive even integers. And in this question, we can solve by putting the values of a and b. For example, let's say that a and b are equal to 2. So if we plug in, so negative 2 raised to 2 is 16. Negative 2, 2, 2, 2. It's a 4, negative 4, 4. It's a 2 into 2b, which is also 2, 4 square, and 2 into 2, 4, 2, 4 is a into 2, which is 2 raised to 5th. All right, and this looks the biggest one right here. So our final answer is number B. Question number 8. Which of the following is equivalent to x raised to 2a over b? And we have to check its value. We know that x raised to 2a over b is nothing but b x raised to 2a. All right, and we just need to find its equivalent, and it looks like it matches number b. So our final answer is number b. Question number 9. If x squared is equal to y cubed, for what value of j does x raised to 3j is equal to y raised to 9? And in the question number 9, we have this equation and this equation, and based on that information, we have to find the value of j. As we can see right here is y raised to 9, and here is y raised to 3. So if we cube both sides here, then we can get this y raised to 9 here too. So let's do it. y6 equal to y9. So we have found that y raised to 6 is equal to y raised to 9. So we can substitute this value just right here. x3j, x6, and 3j equal to 6, and j equal to 2. And our final answer is D. In question number 10, and this term is this term, what is the value of k? How about we take this term to the opposite side of the equal sign, and it will become positive, right? So 2x plus 3 equal to k 2 raised to x plus 2x, and this term right here is k plus 1 to 2 raised to x, right? And this term right here is nothing but 2 raised to x multiplied by 2 raised to 3, and this term cancel out, and we're left with 2 cubed negative 1 equal to k, and our answer is 8 negative 1 is a 7. So our final answer is number C. Question number 11. If this term is equal to this, then what is the value of a? All right. So we already know that this term is equal to this term, right? And this term x is equal to, and we can split that and we can share that exponent between these two bases. All right, so this one is nothing but this, and this thing is equal to xa. All right, so x raised to a is equal to 2 multiplied by x 1 over 4, and we get this x raised to 6 over 8, x raised to 3, 4. So our final answer is a equal to 3 over 4, and it's a B. And now let's get into question number 12. If this term is equal to this term, and x is greater than 0 but not equal to 0, in the equation of what is the value of x? All right, so we need to find a value of x, right? So we can write it down. We can modify this equation in this form: 3 root 2 over 2, and x plus 2 is raised to 1 above 2 in the exponent form, and 2 is nothing but root 2 multiplied by root 2, so it has 2 root 2. So 3 root 2 over root 2 multiplied by root 2, so we can cancel out one term, and we are left with this term 3. And here, if we take a square of this equation on the both side, then we can cancel out this term. All right, so take a square root, and this cancel out, and we're left with x plus 2, and 3 square is 9 over 2. So x plus 2, 9 over 2, x equal to 9 over 2 minus 2, x equal to, it's 2 to 4, 9 minus 4, 5 over 2. So, and in the decimal term, it's nothing but a 2.5. So our final answer is A. And now question number 13. If x raised to ac and this term, this, and x is greater than 1, and a plus b is equal to 5, and what is the value of c? All right, so we need to get this expression out of this equation. All right, and how do we do that? As we can see that these two terms has equal base x, and we know that xa multiplied by xb is xa plus b. So why don't we add these two exponents, ac plus bc equal to x30. So we can take common factor c. So we can take a common term c, a plus b equal to x30, and c, and these two have the same base, so exponents are equal. A plus b equal to 30, and c, a plus b is 5, 30, and c equal to 6. So our final answer is C. And now question number 14. If n cubed is x and n raised to 4 is 20x, then what is the value of x? Here it's n raised to 4 and we only have n raised to 3. How about we multiply this expression by n in the both side of the equation? All right, so nx, which is nothing but n raised to 4 nx, and we know that n raised to 4 is 20x. All right, and x cancel out and n equal to 20. And we know from the first equation that x equal to n cubed, and x is equal to and the value of n is 20 and 20 cubed. So the value of x is 20 cubed. And question number 15, and this is our last question. If this term is equal to this, y7 333, and this term is equal to 3, what is the value of x? What is the value of xy? All right, so we need to find the value of xy, and we can see pattern here is that this expression xy has one exponent greater than this expression. It's a 7, it's 8, it's a 6, it's a 7. So what happens if we divide this equation by this equation? So let's see. All right, 8 y7 x7 y raised to 6 33 over 3, and we know that x raised to 7 cancel out here, so we're left with 1x, and y raised to 6 cancel out here, and we are left with y, and it's a 111. So our value, final answer, is 111. And hopefully this video was good. I did my best to come up with answers, and I'm gonna upload more new videos, so stay tuned.